Hi guys. Okay, so what I'm going to do here is put together one of the answers for you for exercise 7. I will do question 3. So question 3 says, this is obviously in Learning Unit 6 for Boolean logic. Question 3 says that a learner will get full colors for a sport if they have attended 80% of their practices and have either won 75% of their games or have achieved provincial colors. So the idea here is you want a variable for each possible condition here, and looking at question 3.1, they are giving you the variables. If they didn't, obviously you could make up your own ones. So question 3.1 is saying write the statement as a Boolean function, assuming that P represents 80% of their practices, W represents winning 75% of the games, and C represents provincial colors. So 3.1, they want us to write the statement out. Okay, so here we go. Okay, so we've obviously got a function here. It's a function of P, W, and C. Okay, they gave us that. And then if we read what they gave us, they said that a learner will get full colors for a sport if they have attended 80% of their practices. So we've got P representing practices. Okay. And, okay, so there's an and. They have either won 75% of the games or have achieved provincial colors. So we've then got a win, okay, either that or they get provincial colors. Okay, so that there is that represents the Boolean function as they gave it to us. So now in question 3.2, they now say use De Morgan's law to write the expression for when the learner will not get colors. Okay, so this here obviously represents when they will get it. So what we want to do is we want to work out, we want the function of PWC, okay, but we want the inverse of it, the not, okay, because that's when they will not get colors. Okay, so let's take the function that we've got above. So we've got P and W or C. And we are going to not the whole thing. Okay, so De Morgan's law says break the line, change the sign. So here we go. I'm going to break the line and I'm going to change the sign. So I've got that. Okay, so I broke the line, changed the sign. So now we can see we've got a not P, so not much that we can do with that. So we've got the not P. But we see that we can also, we can use De Morgan again on this part here. Okay, so we're going to break the line and change the sign. So we've got, there's the sign changed. And we broke the line. So there we go. That's what we have got. That is the answer for 3.2. That is the inverse of 3.1. Now in 3.3, they want us to draw the truth table for this. Okay, so let's think about what we need for that in terms of columns. We've got 3 variables, so we're going to need a column for the P, a column for the W, and a column for the C. So that's 3 columns we need. We need a not P, we can see that. We need a not W column, and we need a not C column. So we're up to 6 columns now. We need another working column for this, okay, for when we work out W, not W, and not C. Okay, so we need another working column for that, 7. And then we need a column for our result. So we're going to need 8 columns. That's what we are going to need. Right. So you can see I came a little bit prepared here. Here are my columns. There's my PWC. There's my not P. Okay, I'm using the single inverted comma here because obviously a word doesn't let me put the bars above the way that I love to do it. So I've got not P, not W, not C, and then I've got not W and not C, and then I've got my result column. Okay, and I've gone ahead and I've put in, obviously we've got 3 variables, so there are 8 possibilities, 2 to the power of the number of variables, 2 to the 3, 8. Okay, so let's fill this in. Right, so not P is going to be the inverse of this column here. So I'm going to have 1, 1, 1, 1, 0, 0, 0, 0. And not W will be the inverse of W. So I'm going to have 1, 1, 0, 0, 1, 1, 0, 0. And then C is going to be obviously the inverse not C is the inverse of C. Right. So now here we want not W and not C. So we are going to AND these 2 columns together. Okay, so 1 and 1, 1. Okay, I know for an AND, if both inputs are not 1s, I'm going to get a 0. Okay, they both need to be 1s for me to get a 1. There, I've got another 1 there, 0, 0, 0. And so my result, if I go back to here, I can see I want not P or, and that final column. So I want not P or with that final column. So I'm going to have this column, not P, or with this column here. Okay, so I can see that I've got at least 1, 1. Okay, I've got a 1 from the not P. I've got a 1 from the not P again. I've got a 1 from the not P again. I've got a 1 from the not W, not C, or not W and C. Then I've got a 0 there. I've got a 0 there. And I've got a 0 there. So that is it. That is the truth table for the function in 3.2, the inverse of 3.1.